Assalamu alaikum and a very good morning to all. I hope you're doing well. Today we're going to be talking about our new lecture, which is about energy and changes of state. So this is the Cambridge Chemistry Checkpoint secondary book. So we'll be doing 1.5 lesson. Our objective for this unit chapter is use ideas about energy to explain changes of state. So let's get started. Okay, so first we will be talking about the forces between particles. So when a substance is in its solid or liquid state, strong forces hold the particles together. The forces between the particles are much weaker when a substance is in its gas state. So over here they can tell you that there are strong forces between solid and liquid in state. The substances which are in solid or liquid state have strong forces, but the substances which are in gas state have weaker forces. Okay? So let's learn about the next one, which is about explaining boiling points. So the boiling point of a substance depends on the strength of the force between the particles in the liquid state. The stronger the force, the more the energy is needed to separate the particles, and the higher the boiling point. So over here they can tell you that the boiling point depends on the particles, the forces of the particles, between the strength and the force between the particles in the liquid state. Okay, and then it also tells us that the stronger the force will be, the more energy it will need, and the more faster the separation and the higher boiling point it will have. Okay, so next is about melting. Let's learn about melting. Now, when a substance is in its solid state, strong forces hold the particles in a pattern. Okay, so when the substance has its solid state, the pattern is strong force. Okay, so second point, energy is needed to overcome those forces to make the solid melt. So when energy is used, the solid melts because energy is used to make solid melt, the force. Okay. Number 3, your hand can supply enough energy to melt a small piece of gallium or an ice cube. So as you know, gallium is a metal and it melts in our hand. It's lower than our body temperature. That's why it melts in our hand. Okay? So enough energy is used for small metal pieces. For small pieces, less energy, more energy is used. Then much more energy is needed to melt copper. So copper is strong. So there's more energy. You should have more energy to melt copper, because from less energy, the copper won't melt. As I told you yesterday as well, that the energy, the boiling point, the melting point, and the freezing point of I showed you the table in the previous lecture. You should check out my channel for 1.4 and you can check over there as well. I showed explaining about the table where it showed about copper, gold, diamonds, steel, stainless steel, all different types of metals were there, and how their boiling point, their melting point, their freezing point is there. So then the next point is the melting point of substance depends on the strength of the forces that hold the particles in a pattern. So I guess I have done about the melting points yesterday as well. So you might have seen my last time's lecture as well. So over here to tell that the melting point depends on the strength of the forces between the object and the particles in the pattern, if they're in the pattern. Okay, the sixth one, the last one. The stronger these forces, the more energy needed to make the solid melt, and the higher the melting point. So if the energy is more, if the forces are very high, then more energy is needed to make them melt, because it's their melting point. It's their melting point at which they have to melt. No one can change the melting point of those substances. Okay, so the next one we'll be learning about energy for boiling and evaporation. Okay, then comes, in a liquid, the particles touch each other. Okay, so as you know, the particles touch each other, but they're not closely packed like in solid. And in gas, they don't touch each other. Then, number 2, strong forces of attraction between the particles stop them from escaping from the liquid. So the attraction between a liquid is very high. So they cannot escape. But in gas, the traction is very less, so they can escape. And in solid as well, they're attracted to each other and they cannot escape. The particles cannot escape, okay? So I'm talking about escape, but the particles can't escape. So the particles in liquid move around. So the particles move around, but they cannot escape. The particles cannot escape and they're moving around, touching each other, but are not strongly packed together. Okay? Some particles move faster than the others. So some particles will move faster than the other ones. The faster moving particles have more energy. Evaporation happens when some faster moving particles have enough energy to overcome the forces that hold the particles together. So why some particles move faster? Because they have more energy. The more energy they'll have, the more faster they'll go. And when evaporation happens, the faster the moving of particles will happen, the more energy will come, and the more the particles will go together, will join together. Next, these particles escape from the surface of a liquid. So the particles will run away, will escape from the surface of the liquid, from the liquid only. So the boiling happens when overall the particles in a liquid move quickly enough to overcome the forces holding them together. So boiling happens when the liquid particles move enough. They move, they shoo away, they go, splatter everywhere. And then they overcome the forces and holding them together. So then boiling happens. The bubbles you see on the containers are boiling. You can see when you're boiling water, so there are bubbles coming at the down part of the pan. Where you have placed the water, there are bubbles. So a liquid needs energy from heating to make its particles move quickly enough. So if the liquid does not get the heating and the particles don't move quickly enough, different types of boiling and evaporation cannot happen because we need energy for boiling and evaporation to happen. So if there's no energy, there's no heating, there's no energy coming from heat. So how can it happen? It's impossible. That's why we use heat for evaporation and boiling. So therefore, a substance can only boil when it is at boiling point. So the boiling points for different substances are, I have told you yesterday as well in yesterday's topic, which was about 1.4, about boiling and sublimation and different types of this, evaporation as well. So over there you can check the table as well if you like for extra information, and it's better to learn that as well. The boiling points of different substances are important. Okay, so the next one is about freezing. Let's learn. I guess I have showed this before as well. It's about freezing. So it's an experiment. A boy wants to do an experiment, so we'll be seeing his experiment for the confusions to go, because many people have confusion like this. So Abi investigates how static acid cools. He pours hot liquid stearic acid into a test tube and lets it cool. He records the temperature every minute. His results are in the table. Abi plots his data on the graph and draws a smooth curve. Okay, so over here, here's the, I have showed the whole graph line. This is the graph and the table is over here. And this is the thermometer, the test tube he used. So, over here, if you might as well see, I can show you. His results are quite simple. Okay, so these are his results. When it was 0 minutes, the temperature was 96. The temperature was 96, and in 0 minutes, when the time was 1 minute, the temperature was 77. When it was 2 minutes, the temperature went to 70. 3 minutes, 70. 4 minutes, 70. 5 minutes, 70. 6 minutes, 70. 7 minutes, 66. 8 minutes, 63. 9 minutes, 61. 10 minutes, 58 degrees Celsius. So over here is his test tube, as you can see. So this is the thermometer he used. This is the static acid, the boiling tube, and the clamp, and thermometer. So as you can see, I have showed the results over here we start from 0. So 0 is over here, right? And his results is 96. So the results go till 96 over here, making it here, right? Then comes 77, and it is at 1. So 1 comes over here, right? 77, almost near to 80 and higher than this point, okay? So it's higher than this point. I may show you by the laser as well, but it's easier if I show you by the mouse. Okay, so over here, as you can see, next is 70. So it's straight. It's straight for the all 5. 5 for 5 turns, like 1, 2, 3, 4, 5. Yes. For the 5 points, it is at 70. It remains at 70. Then it starts to go down. It goes down and till from after 70, it goes to 66, then 63, then 61, and then 58. So 58 is the last point, as you can see, which comes approximately over here. Yes, it comes over here. So then it started from above and then it went down and down and down and down, right? Yes, from 96 it went to 58. So the graph shows that the static acid freezes at 70 degrees Celsius. So it's freezing at 70 degrees. This is the freezing point of all of them. So at this temperature, the particles transfer the energy, and the particles are transferring the energy to the surroundings, and they stop moving around from place to place and arrange themselves in a pattern. So they're arranging themselves in a complete straight pattern. So the mostly the time and the temperature become same when it's at 70. Okay, so let's talk about what we have learned. Okay, so these 2 points are very important. You may write down if you like, because these are very easy. So boiling and melting need energy. Okay, melting and boiling points have an energy. Then energy leaves a substance when it freezes. Okay, so these 2 points are very important. So I hope you listen to my lecture carefully, and thank you for listening to me, and I am so happy for you people, and I hope you enjoyed watching my presentation, and I hope you learned well. And don't forget to subscribe. It's a little favor, only a very small favor for me. Just don't forget to subscribe and click the little bell button to get notifications. Bye. It's better to click the bell button on all, not personified, as you may get the next lectures as well as soon as I upload them. Okay, so I hope you enjoyed it. Bye.